Hello, so today I'm going to do some practice problems over relative motion. So these problems are sort of the things like we see in class, but it's just more practice, and I think it's better if you just see someone do it if you don't understand it, or it's just a good practice to even do it on your own and see if you get the right answers, and it's good practice all around. So the first problem deals with relative motion. All of these will deal with relative motion, but this is only going in one direction, so you don't have to worry about the other directions or thinking about that. So an airplane goes at 921 kilometers per hour relative to the air. So if you draw your little airplane, excuse my airplane, I'm not very good with airplanes, but okay, so it's going at 921 kilometers per hour relative to the air. It is flying from point A to point B west. So it's going to go to the west, a distance of 1,000 kilometers. So this is going at 921 kilometers per hour west. It will then return from point B to point A. There is 70 kilometers per hour wind blowing to the west. So we already have the airplane here that is going to the west. And now we are told that the wind is going to also be blowing to the west. So you can just add that to your free body diagram, 70 kilometers per hour. So this is when it is traveling. This is a very informal body diagram, but bear with me. So this is airplane west. And then we can draw another one if you want to, which is airplane to the east. And this airplane this one's going from point A to B, and this is going from back to point A from B. So then this one is going to have to go to the east, and it still has the same speed. And the thing is, the wind is still going in the opposite direction, so it's going to be going to the west. So we have that. Now in this one, the wind is working with it. In this one, the wind is working against it. And we're trying to find out the difference in flight time in minutes between those trips there and back. So first thing is we are trying to find the minutes this one will take and the minutes this will take, and then we will find the difference and get our answer. So how I would do this is, let's look at all our variables again. So we have this, we have this. We should write down the total. We have all of these things. Now what we should do, we should write down the total distance that they would all take. So let's write it down here, 1,000 kilometers. So from here, we are going to do 921 plus 70, since the wind is working with it. And that is going to be, oh, that's simple math. I should have just known that. Whatever. Kilometers per hour. And when you're trying to find the minutes, what you can do, you can divide your total distance by your velocity, and you're going to get the time it takes. And that will be 1.00908. And the thing is, I like to do around like 4 to 5 just to make sure it's more accurate. We can do that, and then what you're going to do is you're going to multiply this times 60 since you want to know in minutes. So it's going to be times 60. And overall it's going to take you 60.5449 minutes. This one. And then this one will take you, remember this one's working against, so what we're going to do is 921 minus 70, and so one is working against you. So this is 851 kilometers per hour. And you're going to do the same thing, 1,000 divided by 851 kilometers per hour. which will give you 1.17508, and if you multiply that times 60, you get 70.505. 2, if you want to be more specific. So then you're gonna get this number, and you're going to subtract that. So you get the biggest number, you're like, okay, now I have 70.5052 minus 60.5449. From this, you get 9.9603 minutes. And this is your answer. That is the flight time difference from this problem.